Okay, welcome to video 9. Today we're going to do more with piecewise functions. In exercise 1, we are given this function f of x equals 3x plus 1 when x is less than 2 and negative 6x plus 10 when x is greater than or equal to 2. We want to find the average rate of change. Now remember, that's just another word for the slope. So above that I'm going to write slope. Over the interval, 1 is less than or equal to x is less than or equal to 5. So that means that the two pieces I look at is 1 and 5. So if we look at our piecewise function, whenever the x values are less than 2, we're going to use this top function. And whenever the x values are greater than or equal to 2, we're going to use this bottom function. So the first one I look at is this 1. Well, I think that 1 falls in that top interval. And that's because 1 is less than 2, so it fits in that domain. So that means to find f of 1, I'm going to plug 1 into the equation. So f of 1 equals 3 times 1 plus 1, so that means f of 1 equals 4. Now that tells me that the first point that I care about is an x value of 1 and a y value of 4. So I'm going to write that as 1 comma 4. Now I need to look at the second piece, the 5. 5 is greater than or equal to 2, so that means that I'm going to use the bottom function for the 5. So to find f of 5, because 5 is greater than or equal to 2, I'm going to use that function. F of 5 equals negative 6 times 5 plus 10, which simplifies to be negative 20. So that means that my second point here is 5 comma negative 20. So now I have my 2 points that I can find the slope between. If it helps you, you can write out the formula, which is m equals y2 minus y1 over x2 minus x1. You can put x1 and y1 and x2 and y2 under the points if it helps you. And then we just fill in each piece into the equation. So when I plug those in, I get negative 20 minus 4 divided by 5 minus 1. Negative 20 minus 4 is negative 24. And 5 minus 1 is 4, so negative 24 divided by 4 gives me a slope of negative 6, and that's my answer there. So remember, the important thing with piecewise function is determining which piece we want to use based on the given domain. So we had to look carefully to make sure that the x value was in the given function. So it happened to be that this one was in the top function and the 5 was in the bottom function. So always just remember to check those domains. This next example says that given the function f of x, and we're again given a piecewise function, so I just like to highlight the top and bottom in different colors so we know that there's different functions. So we're going to answer the following questions. F of negative 1. If we're looking for negative 1, that's the x value. So which one does negative 1 fit in? Is negative 1 less than negative 1? No, that's not true. So we have to look at the next piece. Is negative 1 greater than or equal to negative 1? Well, it's equal to, so that means that we're going to use the yellow function to find f of negative 1. So I get negative 4 times negative 1 plus 8, and then when I simplify that, and again we can do that with our calculator, I get 12. So f of negative 1 equals 12. Now the next piece tells me to algebraically determine the zeros of the function. So the zeros, that means that it's crossing the x-axis, which means the y value is 0. So I'm going to plug in y 0 and then solve for x. So first I'm looking at the pink function. 0 equals 2x plus 6. Now I need to solve for x. So first I'm going to subtract 6 from both sides. So when I do that, I get negative 6 equals 2x, and then to get x by itself, I need to divide by 2. And when I do that, I get x equals negative 3. Or negative 3 equals x, either way is fine. Now I need to check to see if that is in the given domain for the pink function. So the pink function means that it needs to be less than negative 1, so I'm going to write negative 3 is less than negative 1. Then I need to determine if that's true. Is negative 3 less than negative 1? Yes, it is. So that's a true statement. That means that that is one of the answers. Now I need to check the other function to see if there's a 0 on that side. So now I'm going to do the same thing, but with the negative 4x plus 8. So 0 equals negative 4x plus 8. First thing I'm going to do is subtract 8 from both sides. And then I get negative 8 equals negative 4x. Now divide by negative 4 to get x by itself. And I get my answer of x equals 2 or 2 equals x. So now I also need to check in that domain, is 2 greater than or equal to negative 1? Well, yes, that is also true. If either one of these were false, I would simply reject it. But since both were true, that means I have two answers. So I'm just going to write it in set notation. So my answer is x equals the set of numbers negative 3 and 2. And again, remember to just always check the domain. We'll go over this more in class. Have a good night.